Let's briefly look at an example which will show us how simple it is to identify the real I/O field devices which can be connected to the PLC. Then we'll assign the input and output addresses for real and internals, and finally, we'll draw the I/O connection diagram of the identified field I/O. Now first, we'll specify our PLC as having addresses 000 octal through 017 reserved for inputs, 020 through 037 for outputs, and having internals that start at address 1000. The modularity, that is points per module, is 8 for both inputs and outputs. By first inspecting the electromechanical relay diagram for inputs, we find that the real input field devices are those that receive input sensing control signals. For example, in the first line of the electromechanical ladder, we have the start push button PB1 and the stop PB2. These are, of course, two real inputs. We'll get to the outputs next. In the second line, we find contacts CR1, which come from control relay CR1 in the first line. These contacts are not real inputs because they are used for interlocking and do not represent a real input field device. In line 3, we have the normally open temperature switch TS3 as another input. In line 5, we have the float level switch FS4. In line 7 of the ladder, we have the normally closed float level switch FS5, while in line 10, we have the temperature switch TS3 again. Note that this time TS3 is normally closed and that we're referencing it here as a notation for real inputs. As you can recall, we only need to bring one of the two switch contacts from the temperature switch and program them accordingly. As you can see, we have only identified the real input field devices that will form part of the input section of the PLC system. Now let's start identifying the real outputs that are to be controlled by the PLC. In the first line, the control relay CR1 is not going to form part of the real PLC outputs because we can implement it using internals. This control relay is used for interlocking and does not drive a real field device per se. In line 3, again we find another control relay, CR2, used for interlocking. However, in line 4, being driven by the same logic, we have the ready pilot light, PL1, which is a real output. In line 5 and 6, we have the open solenoid 1 and also the pilot light, PL2. In line 7, we have as real outputs the solenoid 2, and in line 9, the light PL3. In the last rung, we have the heating element, or heater, H3. In this control diagram, we have 5 real inputs, of which one is used twice, the temperature switch, TS3, and we have 6 real outputs. Once we've selected the real inputs and outputs, we can proceed with our requirement of assigning the addresses for inputs and outputs. As we know in this example, we have available for assignment from inputs 000 to 017 and for outputs from 020 to 037. To assign the inputs, we simply say that input 000 will be PB1, 001 will be PB2, and so on until we cover all the real inputs we've identified. Note that the temperature switch TS3 is only assigned one address since it's the same field device, and as we know, we can have multiple use of input device addresses. We assign the outputs in the same manner. The first output we find, we assign to it the first available output address 020 and so on until we cover the last real output. As you can see, the assignment is not difficult as long as you know which I/O will have which I/O address. As a matter of fact, this type of tabulation of I/O address assignment can be kept as part of your system documentation for future reference. In order to assign the internals that will form part of the control program, we have to reference the control relays that are used for interlocking. So for CR1 in the first line, we assign the first of internals address 1000. Control relay CR2 will have the same address as the PL1 ready light since the driving logic is the same and can be used also whenever contacts from CR2 are employed. The same applies for the control relay CR3, which uses the same address as the solenoid 2 or the light PL3. Either address, 023 or 024, can be used for it. In this, we'll use 023, which corresponds to the solenoid's output. The illustration of the I/O connection diagram is also very simple to do if we have done our work properly. We simply take each of the identified inputs and outputs as tabulated in the real I/O address table and graphically connect them to inputs and outputs modules. Note also that we've represented the normally closed TS3 in the diagram, but we have not connected it. Although industry standards for representing input and output modules graphically vary among users, we have, throughout our whole training program, used squares to represent input modules and diamonds for the output modules. The key is to be consistent.